we're going to do for matrices. So you tell me if you have any problems. Now remember, when you're finding an inverse, you have to multiply both ways, a times b and b times a. It has to be both ways to do this, and they both have to come out with the identity. This is your identity one. Series of like ons and offs, zeros and ones. You tell me if you have any questions as I roll through these. Again, to find the inverse, just put in the a to the negative 1, that's your inverse symbol, and flip it to a fraction. And not all square matrices will have an inverse. It has to be a square to even have an inverse, but not all of them will have an inverse. Good so far? Most of this, write on your calculator. Write on your calculator. Use your inverse key. Write on your calculator.
So to check, do you feel like a times a to the negative 1?
The a times a to the negative 1 will give you the identity one. That's another way to do it too. A times a to the negative 1 will give you the identity one. A times, if you've given two of them, if you only have one, so you do a and then a to the negative 1. Yeah. But if you have a and you do a to the negative 1, if it doesn't have an inverse, it won't give you one. It'll give you some kind of message. It might be singular, it might be something else. Okay? Then we did your using an inverse to solve your equations. You're going to just separate your coefficients and your constants. You're going to do the inverse of a times b, and you're going to get a little single row answer here, little single column answer. Again, you've got to flip those to fractions because you can't round off any of your irrational decimals. Good. All good so far? This one had no inverse, so therefore we couldn't do this.
Did you just put no solution?
Well, there might be a solution. There just is no inverse to it. You might, if you want to look for a solution, you might want to do RREF, but this one has no inverse, so we can't do the inverse part. You just say no inverse. And then this is kind of a nice way just to get them listed all the way down. It means you have to set them up in two matrices versus one with an RREF. Or one with an REF and then solve backwards. Today we're going to look at the last way to solve the systems of equations that we use. Questions? We're good? Inverses are nice. Nice and easy. Not a lot to them. Alright, again, take a look at them and tell me if you have any questions. Our REF is nice. Put it all the way in, pull it out, and there's your answers. You're looking for this, whoops, this situation.
For number 2, since W goes before X, but so like if you put it in the parentheses, it'd be negative 3, 2, 4, negative 4.
Yeah, but the thing with this is, it's in the order of this one. This one's a weird one. Normally they don't do this. Normally they would put W first, but we have to put it in the order of this. So I wouldn't even do that. I would just list them.
Okay.
Technically, they should be alphabetically, and our things. Oh, we have to go see Miss Krause. Okay. So just take this with you. Yeah. Normally, they would put them in order over here, but for some odd reason, they loop the W on the end. So we'll just loop the W at the end. You guys go with the RREF? Okay. Okay, find A minus B. Everybody okay with this? These guys, you can do these on your calculator. Multiplying by a scalar, multiplying by a negative, adding them, subtracting them. The only ones we really want you to do out are the multiplies. We need you to multiply out. So we have a 3 by 3 times a 3 by 3, so we know we can do this. Always check first. The inside ones have to be the same, and your result is the outside one. Everybody can do this. Multiply out. You don't have to show all the parts that I show. You can do this part in your head. That's fine. I do it this way, so that I see them lined up, so that you see them lined up. Okay. Good review. This one, we couldn't do this. It's undefined. I just asked you to see, can you multiply these? Yes, you can. Yes, you can. The inverse doesn't exist, and there's that, excuse me, that inverse. Using inverses. Everybody good with this? Yeah, absolutely. You didn't have to multiply it out, and this one couldn't be done, because this is a 2 by, they wanted C. You have to go in the same order. Remember, this is not commutative. The only time it's commutative is for an inverse. So you had to go from C to B. It's an associative property. You can do it regrouping, but you can't do commutative unless it's an inverse. And the last one, this is it, right? Are we good with this? Yeah.
Can you go to number 8 a second?
Which number, hon?
Number 8.
Number 8. Two by 3 and 3 by 2.
Yeah, so this one.
It said don't solve, right?
No, it said 2.
Oh, it said to solve? Oh, okay. I didn't solve.
Yeah.
So we're good with these? Just that you're going to multiply, and you're multiplying up this way. You're multiplying this way. It's multiplying up like this. This way minus this one. So A1 times B2 minus A2 times B1. So I go like this. Like your means and extremes when you do a cross multiply in a ratio. You know your means and extremes when you make a ratio?
Yeah.
Kind of like that. So you go up this way minus up this way. The order matters, because if you go the opposite way, it's different. And then you just subtract, take the opposite, and add. So your determinant for this guy would be 7. Now in your calculator, it's kind of nice in your calculator, because when you put this matrix in and you go to calc, the first calculation it hits is determinant. So if you put this in your calculator and you go to determinant, click on whatever one you put it in, A, and it'll give you the determinant of that. It's a special number associated with your matrices. It's sitting right there on number 1 when you do this. So try putting this guy in. We don't ask you to find this by hand. There's a whole pattern to this. Sometimes colleges make you find them by hand, but we don't. So put this guy in your calculator and find me the determinant. And
Yeah.
14. Everybody get 14? Okay, that's that's how simple the determinant is. Generally, with the determinant, we use the straight bars rather than the brackets to denote that we're looking for a determinant. Now, one of our nice uses for a determinant is finding the area of the triangle. Kind of like I was just telling you, when you do geometry and you have to plot your points and you have to figure out where your base is, the distance formula, drop your altitude, find a perpendicular slope to it, make that line. You go through all of this, a determinant would be nice. Now, very, very simply, it has a nice little area formula. The reason we give it a plus or minus is because sometimes your determinant comes out negative. Your area cannot come out negative. So if your determinant comes out negative, then you're going to just multiply it by a negative number. And you'll keep your determinant and your area will be positive. If your determinant comes out positive, you're going to just multiply it by a positive number. The positive 1/2. And your area comes out positive. So it has a little fail-safe thing in here. Now the trouble with this is, the determinant has to be a square. That when we list your vertices of your triangle down, we don't get a perfect square. So we fill that last column with ones. Always ones. Because if you just left it like this, you don't have a square. So we're going to fill this in with ones. And going to find the answer to your area. It's that simple. So when you do this, you're going to start like this. You're going to put your vertices out here. And you're going to say, can't do this determinant because it's not a square. We're going to fill this with ones. So find me the determinant of this matrix. What's the determinant?
I got -3.
-3. Sounds good to me. Now, because this is negative, you're just going to use the negative part of your formula. So that we can multiply -1/2 times -3, and your area will stay positive. It beats the heck out of graphing this thing. It's a pretty small little triangle there at the sides. Finding the distance, dropping an altitude if you don't have a right triangle. It's kind of a quick way to find the area of a triangle. This is one nice use for a determinant. Guys good with this? Pretty simple? The second nice use that we're going to do, and there's many, is called Kramer's rule. And Kramer's rules, it's going to use your determinant to find the answers to your systems of equations. We do this a little bit differently. Excuse me. We have to separate these between the solution, between the constant, and the coefficients. So we're going to make two matrices. Okay, we're going to make two matrices. We're going to do your coefficient one, and we can, when we do these determinants, we can never have a determinant of 0, and you're going to find out why in a second. And we're going to make a constant with your coefficients. We're going to take the determinant of the total one. This we're going to call capital D. So this will be -20 minus -6. So this comes out to be -14. Okay. Now, to do Kramer's rule, I don't think I have enough room here. I'm going to have to do it here. So this is your x, this is your y. Alright, we're going to take this column with your constant, and if we want to solve for the x, we're going to replace the x with this. So we're just going to put this in and say 10, 11, negative 2, negative 5. And we're going to find the determinant of this guy. We're going to replace the x. So we're going to say the determinant of x is equal to, this will be negative 50 minus a negative 22. So what does that come out to be? 28? Negative 28? Okay. Now we're going to use this formula down here. We're going to take the determinant of x over the determinant, and we'll find the solution for x. So we take negative 28 over negative 14. Therefore, x is equal to 2. Okay, we just took the coefficients. If we're solving for x, we're going to put the solution part in there, the constant over the x.
Above the determinants there, what does that say up here?
I did the determinant out this way, so negative 50 minus negative 22. If you have a 2 by 2, you can do that out by hand. Yeah. Then we're going to do the same for y. We're going to take this column and replace the y. We're going to put the x back to where it was. And we're going to find the determinant. So multiply up, 44 minus 30. So the determinant for this guy is 14. And again, you're going to use the same formula. Determinant of y over the total determinant. So you're going to put 14 over negative 14, and y is equal to negative 1. So we have an x and a y. This is called Cramer's rule. Using the determinant, we just fill in that column with your constant. This has to give us a square. If it doesn't give us a square, we're in trouble. We can't do it. But if you kind of think about it, if you have 2 variables, you have 2 equations, 2 spots. 3 variables, 3 equations, 3 spots. So it kind of gives us a square. Good? Not bad. It gets a little bit, well, not really that difficult. If you throw another variable in, it just means you do this another time. And then you can't do them by hand as easily. You have to keep putting them in your calculator. So let's have you guys try one. Let's have you guys try this. Let's set up the matrices first. Okay, remember you're going to find a determinant. This is your major determinant. This is your constant. Okay, so find the determinant of the entire thing first. Okay? And then last, you're going to do z. Notice the bars for determinant. So last, we're going to do z. We're going to go back to the original x. We're going to go back to the original y. You're going to replace z with your constants.
So if you do like brackets instead of bars, is it wrong?
I'm not going to take points off, but technically a determinant should have bars. I'll just write the bars over your brackets.
There's no like around some down.
Yeah.
It does, but it's the way you denote a determinant as well. So we get 164. So we get 164 over 82 over negative 82, and z is equal to negative 2. So your solution is 5, 8, negative 2. Okay. God bless you. A little different. but it makes good use of a determinant. So you saw a determinant used to do the area of a triangle and to solve systems of equations. These are pretty powerful. We do inverses to solve the systems of equations. We do